Today's topic is relations and functions, and we have quite a few definitions that we're going to have to cover before we get into the example problems so that we can understand what the example problems are asking us to do. A relation is a set of ordered pairs, so we're talking about the ordered pairs of points that you would plot on a graph. Domain means all of the x values in a relation. So in those ordered pairs, all of the x coordinates make up our domain, and the same thing with range. We've seen the word range before in algebra, but last time we saw it, it was talking about statistics. This time it's something that means a little bit different. We're talking about the y values in a relation. So if you look at the example relation that I have below, I have 5 ordered pairs in between these curly brackets, and if I ask you to find the domain, you look at all the x values. So the domain would be 4, -2, -1, 4, and -1. If we're talking about the range would include 3, 1, 3, -2, and 1. Now if you have a function, that means that you have a relation whose domain does not have any repeating values. So in other words, it means that none of your x values are going to repeat. And we have 3 tests for determining whether or not a relation is a function. The first one is the vertical line test, which we'll see in example 1. The next we have a mapping diagram, and the third method is just what I call the look method. So how about we check out example 1. It says use the vertical line test to determine whether the relation is a function. We have 2 graphs in example 1, and we're going to use the vertical line test for both of these. And what the vertical line test means is we're going to take a straight edge. It could be your pencil, it could be a ruler, it could be a straight line, and we're going to draw that on top of the graph. And if our function line, so in our left graph it would be this red line, and the right it would be the sideways parabola here. If the function line crosses our vertical line more than once, it is not a function. So let's take a look at our first one here. I'm going to grab a vertical line tool, and I'm just going to draw a line. Now, as you can see, our function line is only touching our vertical line test once here. And if I take this black line and drag it all the way across, or if I just draw a lot of them, no matter where I put my vertical line, it's only going to intersect our function line one time. Each of these intersections only shows up once on our vertical line. So that means that our first graph passes the function test by the vertical line, and so we would say yes, it is a function, and we would write function beside it. Alright, if I do the same thing for our parabola, we test it with our vertical line. This time, when I put it down, you can see that our parabola function is intersecting our vertical line twice. That means it immediately fails the test, and so this is not a function. And we would write not a function beside it. So there's one test for determining a function. The second test we have is what is called a mapping diagram, and there's some simple things to remember about a mapping diagram, and we have that up here in red and green. When you draw a mapping diagram, we're going to be counting the values in the domain and counting the arrows that we use in this diagram. And if those numbers match, it means that we have a function. And if the numbers are different, it means that we do not have a function. So let's talk about drawing our mapping diagram. We're first going to start out with 2 rectangles, or 2 circles, whatever you choose to draw. One of these represents our domain, and that'll be the one on the left, and the other represents the range. Now we need to figure out which numbers are in the domain and which are in the range, and if you'll recall from our definition, domain is all of our x coordinates. So let's look at our x coordinates. We have a 2 that's negative, a -1, 6, and another -2. And what I'm going to do is write those down. But here's the trick. If I have a number that repeats more than once, I only have to write it down one time. So I see that I have a negative 2 here, and then a negative 1, and then a 6, and then negative 2 shows up again, but I'm not going to put it down in my domain box because I've already got it down there. I'll do the same thing for range. Range is the y values. We have negative 1, 0, 3, and 1. So I write down negative 1, 0, 3, 1. And the next thing we're going to do is connect our domain to its matching range. So let's look at our first ordered pair. We have negative 2, negative 1. That means that the negative 2 in the domain goes with the negative 1 in the range. Our next ordered pair, we have negative 1, 0. So I'm going to start at negative 1 and go to 0. The next ordered pair we have is 6, 3. So I draw an arrow from 6 to 3. And the last ordered pair that we have is negative 2 and 1. So we're going to draw an arrow from negative 2 to positive 1. Okay, now according to our helpful shortcuts here, we're going to have to count the domain values and count our arrows. So our domain values, we have 1, 2, 3 in the box. And we have 1, 2, 3, 4 arrows. Let's look back up here at the rules. It says if they're the same, it is a function. And if they are different, it is not a function. We know that 3 is not the same as 4. So in this case, this is not a function. And we'll write that down. Let's move on to example 3. Example 3 asks if the relation is a function, and we're going to use the easiest test of them all and use the look test. Alright, so the look test is basically where you look at the domain values. If any of them repeat, it is not a function. If they are all different, then it is a function. So the question says, is the relation a function? Let's look at the A example. We have 11, 12, 13, and 20. All 4 of those numbers are different. So in answering the question, is the relation a function, we would write yes. For the look test, you don't even have to worry yourself about y's. The y's are not important. Let's look at the B example. Our domains, we've got 5, 0, 5, and 1. And if you'll notice, we have 2 of them that repeat. 5 and 5 in the domain. And since they repeat, the look test says, no, that is not a function. Pretty simple. Alright, we have a few more definitions to cover. Almost finished. We have the definition of function rule, which means that it is an equation that describes a function, and function notation is f parentheses x, and we pronounce that f of x. And f of x and y are used interchangeably to indicate the output of a function. So when you're working with function rules, we're going to have input, a number that we're going to put into the equation, and the output, which will be f of x and y, will be our answer. So with example 4, we have evaluate f of n equals negative 3n minus 10 for n equals 6. Lots of words, but a very simple solution. What this means is we're going to take this n equals 6 and we're going to plug it into our function rule. This is our input. Input is 6. We're going to plug it in. So we're going to write down negative 3 times 6 minus 10. And we're just going to evaluate this. Negative 3 times 6 is negative 18. Negative 18 minus 10 is negative 28. So when we evaluate our function negative 3n minus 10 for n equals 6, our answer is going to be negative 28. And that's what we'll write. We're done. Example 5 is basically the same thing, except it's worded a little bit different. Example 5, we see that it says evaluate the function f of a equals negative 3a plus 4 to find the range of the function for the domain negative 3, 1, 4. And what this means is that we have a domain of -3, 1, and 4, and they're interested in the range values. They want to know what the y values will be when we plug each of these in. So this one's like having 3 problems in one. We have 3 domain values, and we're going to get 3 range values for our answer. Let's start with -3 since that's listed first. So we're going to have f of a is equal to -3a plus 4. And now this time, instead of writing an a, I'm going to plug in -3. And we're going to evaluate this. -3 times -3 is 9. 9 plus 4 is 13. Here's one of our answers. We're going to do the same thing with 1. We have f of a and then our function rule. Okay, this time instead of plugging in an a, we're going to use positive 1. -3 times 1 is -3, and -3 plus 4 is positive 1. So when the input is 1, the output is also 1. Last domain value to use for, I'll put that down here. Okay, instead of using a, we're plugging in positive 4. -3 times 4 is -12. -12 minus 4 is -16. So we had 3 input values, we get 3 output values for the range, and here's how we're going to write our answer. We are going to use the brackets like they did for the domain, and we're going to list these in order from least to greatest. The smallest number that we found is -16, so I'm going to write that first. After that, we have a 1, and after that, our largest answer was 13. And then I'll close the brackets. So the answer for example 5 is actually 3 answers, and we're going to include them in a set. It is -16, 1, and 3. That will conclude today's video. Have a great day.